for a normal distributed variate with mean 1 and SD3. Find the probability that 3.43 less than or equal to x less than or equal to 6.19 minus 1.43 less than or equal to x less than or equal to 6.19. That probabilities we need to find. To find that probabilities, first what is given, note down. Given data, given in normal distribution, mean is given, mean mu equal to 1, standard deviation sigma is given 3. So in normal distribution we know z equal to x minus mu by sigma. So to find probabilities in normal distribution, you need to find corresponding z values for given x values. Now we need to evaluate probability of 3.43 less than or equal to x less than or equal to 6.19. What I am saying, you need to find z corresponding 3.43, 6.19. Z values corresponding 3.43 and 6.19. How to find? By assuming this one as x1, find out z1. Z is x minus mu by sigma. Z1 is x1 minus mu by sigma. What is x1? 3.43. 3.43 minus mu is 1 by sigma value 3. 3.43 minus 1, 2.43 by 3. Use your calculator to get the value. The value is 0.81, which is positive value. Z1 is positive. Coming to x2, let x2 is 6.19, z2 equal to x2 minus mu by sigma. What is x2? 6.19 minus 1 by 3. So if you calculate that value, 6.19 minus 1 by 3 value, you will get 1.73. Okay, any doubts you may express anywhere. 1.73. Now Z1, Z2 values we are having. Now we need to find P of 3.43 less than or equal to x less than or equal to 6.19. We converted this one like this. Probability of Z1 less than Z less than Z2. So 3.43 is x1. This is x2. We converted that one like that in terms of z, using z equal to x minus mu by sigma. Now we need to draw the region of integration so that we can find the area. So this is normal curve. It is in bell shaped. A normal curve is a bell shaped curve. Area under normal curve is 1. Total area under this curve is 1. It never enter into x-axis. It has maximum value at x equal to mu. And the total area is divided into two equal parts. This is z equal to 0 or x equal to mu line. Total area is divided into two equal parts. Right hand side area 0.5. Left hand side area 0.5. Now you will have here negative values. Here you will have positive values. One side negative values you will have, another side positive. Now both Z1 and Z2 are positive. Z1 is positive, Z2 also positive. Both are positive. Positive means you will get this side. Z1 this side. Z1 is 0.81. This is Z1. Z2 is 1.73. That is, this is Z2. Area of Z1 means from here to here. Area of Z2 means from here to here. Now what we need? Probability between Z1 to Z2. So this is required probability to us now. This is required area or required probability. So how you will get probability between Z1 and Z2? Z2 represents area from Z equal to 0 to here. Z1 represents area from here to here. If you subtract this area from total area, you will get the shaded area, required area. What I am saying, if you do like this, area of Z2 minus area of Z1 will be the area between Z1 and Z2. So Z2 is, Z2 value we know, Z2 is 1.73, Z1 is 0.81, Z2 is 1.73. So 1.73 minus 0.81. So 1.73 means in Z distribution table will be like this. So you will have Z equal to x minus mu by sigma. Here you will have Z values like this. The table will be like this. I will show you the table. Here, this is the table. Area under normal curve 0 to x minus mu by sigma. Here x minus mu by sigma is Z. These values will be like this. 0.0, 0.1, 0.2. Like that you will have up to 3.1. Here you will have 0.00, 0.01, 0.02. Like that you will have up to 0.09. So this is the table. This table will be given in the exam to you. You can ask for stats table. For every probability and statistics exam, you require some statistics tables. From this table, you can get A of 1.73. A of 1.73 will get in 1.7 line under 3. 1.7 line under 3. What I am saying, here if you have 1.7, in this line under 0.03, you will get 1.73 value. 1.73 value here, you are having 0.4582. Similarly, 0.81. So, for example, if you have here 0.8, under 0.8 under 1 here. 0.8 line under 1. 0.2910. Like this, you need to see the table to get the area. Here, if you subtract the two values, you will get required area 0.1672. Are you clear? How to get the values? Any doubts you may express, I will explain. Any doubts you can ask me. Now coming to the second bit, minus 1.43 less than or equal to this one. 43 less than or equal to x less than or equal to 6.19. By taking x1 minus 1.43, we need to find z1, x1 minus mu by sigma. x1 is minus 1.43, mu is 1, sigma is 3. If you calculate this value, you will get minus 0.81. Z1 is minus 0.81. Z2 will be same. X2 6.19 here also. Z2 value will get 1.73. This value only. This value only we are using here. Now, probability of minus 1.43 less than or equal to x less than or equal to 6.19 is probability of z1 less than or equal to z less than or equal to z2. That means we need to draw the diagram first. So if you draw the rough diagram like this, here both the values are positive, sorry, one value is negative and another value is positive. So Z1 is negative, this is negative, this is positive. So negative should be drawn left side. So this is Z1, because Z1 is negative, that is drawn left side of Z equal to 0 line. This is Z line. Z2 is positive, you need to draw here. Now we need area between Z1 and Z2, this area required. How we will get that area? By adding area of Z1 and area of Z2. Area of Z1 means A of Z1 value. Z1 is minus 0.81 plus A of Z2 1.73. Because area, if you have negative also, you will see in positive only. 0.8 under 1. Already we took that one value for previous problem. Same value 0.2910. 1.73 also we are having 0.4582. So if you add these two values, you will get the required probability between that values 0.7492. Okay? Any doubts you may ask? X is normally distributed with mean 8 and SD 4. Then find probabilities this one and this one. Probability between 5 and 10 and probability less than or equal to 50. These two we need to find. So in normal distribution given, mean is 8, standard deviation sigma is 4, and in normal distribution formula for Z is x minus mu by sigma. X minus mu by sigma. Now Z value x minus mu by sigma, we need to find probability 5 less than or equal to x less than or equal to 10. To find probability of 5 less than or equal to x less than or equal to 10, you need to find Z values corresponding to 5 and 10. That means let x1 equal to 5. Then Z1 is x1 minus mu by sigma. What is x1? 5 minus 8 by sigma 4. So 5 minus 8 by 4 you need to do. If you do, you will get minus 0.75. 5 minus 8 minus 3. Let x2 equal to 10. Z2 equal to x2 minus mu by sigma. 10 minus 8 by 4. 2 by 4. 0.5. This is negative, this is positive. Now we need to find probability between x1 less than or equal to x less than or equal to x2. This we are converted like this. Probability of Z1 less than or equal to Z less than or equal to Z. So now probability between Z1 and Z2 we need to find. For that you need to draw the normal curve so that you can understand what is the required area we need to evaluate. So this is Z equal to 0 line or x equal to mu line, Z equal to 0 or x equal to mu. Now Z1 is negative. If Z1 is negative, you need to draw left side because Z1 negative. Left side of Z equal to 0 line. Z2 is positive, you need to draw right side. This is Z2. Now we need to find area between Z1 and Z2. That means this is required area. This area we need to find. Area between Z1 and Z2. That means area from Z equal to 0 to Z1 and Z equal to 0 to Z2. That is area of Z1 plus area of Z2. Area of Z1. Z1 is minus 0.75 plus A of 0.5. So area of minus is plus only, A of minus Z is plus A of Z. That's why you need to see these values in the table, Z distribution table. Under 0.7 under 5, you will get 0.75 value. 0.5 value beside 0.5 in the table, you need to see. You will get these two values from Z distribution table. Z equal to x minus mu by sigma table. So these values are 0.2734 is one value. Another value 0.1915. So if you add these two values, you will get probabilities between Z1 and Z2 0.4649. Use calculator. These two values are from table, Z distribution table. Z equal to x minus mu by sigma table, normal distribution table, we call it as normal distribution table. Next, coming to the second bit, P of x less than or equal to 15. X less than or equal to 15 means corresponding to 15, you need to find Z1 or Z. Let x1 equal to 15. Let x1 equal to 15, Z1 equal to x1 minus mu by sigma. 15 minus mu is 8 by sigma is 4. So Z1 value will get 1.75. 15 minus 8 by 4 if you do, you will get Z1 1.75. Now we need to find probability of x less than or equal to x1 means Z less than or equal to Z1. So if you draw normal distribution curve, this is Z equal to 0 line, Z less than or equal to Z1. Z1 is positive. Positive means you need to draw right side. Z less than or equal to Z1. Area of Z is Z less than or equal to Z1. That means less than Z1. Less than Z1 values, where you will get? Will you get this side or this side? Right side of Z1 line or left side of Z1 line? Less than Z1. Less than Z1 values, you will have this side only. This side. For example, if you have 2, here you will have 3, 4, 5, 6 like that. If you have 2 here, here you will have 1, 0, minus 1 like that. So less than Z1 values you will get this side only, up to this side. So this is required area. But we know that this portion from here to here is 0.5. From here to infinite distance 0.5 plus this area we need to add. That is 0.5 plus area of Z1. 0.5 plus area of Z1 is 1.75. This A of 1.75 value you will get from table. That value is 0.4599. This value. This is from table. So if you add these two, you will get final answer 0.9599 is required probability between Z1 and Z2. Any doubts you may express. The marks obtained in statistics in a certain examination found to be normally distributed. If 15% of the marks of the students are above 60, 40% of the students are under 30, find mean and SD. So in the previous cases, mean and SD are given, we need to find probabilities. But here different, probabilities are given, we need to find mean and SD. In reverse way we need to do. So now, what is given? Probability of 15% of students, 15% of the marks of the students are above 60 means P of x greater than or equal to 60 is 15%. 15% means 0.15. And P of under 30 means x less than or equal to 30. Or 40%. 40% means 0.4. Now, if you take the normal distribution curve, in this half area is 0.5. If you subtract 0.15, that means x greater than or equal to 60 means you will get right side, less than 60 you will get left side. This is Z line. Less than 60 you will have this part, greater than 60 this part, greater than part. So 0.15 means this area is given. This area is given 0.15. And here this area is given 0.4. We need this area. Actually, in the table we see from Z to here is table value. So this area you will get by subtracting 0.4 from 0.5. 0.5 minus 0.4. There you will get the value 0.1. Similarly here 0.5 minus 0.15. So that is this area 0.35. Okay, now what is this 0.1? If you assume this one as Z1, this one as Z2, we know the formula for Z1 is x1 minus mu by sigma, and formula for Z2 is x2 minus mu by sigma. What here we are having? X1 minus mu by sigma equal to this area we know. That means A of Z1 we know. What is Z1 we need? Here A of Z1 we know. Area of Z1 is this part 0.35. We need Z1. Here also area of Z2 no 0.1. We need Z2 and Z1. Here we need to write Z1. How you will get Z1? This value you will get from table. From table you will get this value. In the table, I said in the previous problem, this is Z distribution table. Here you have Z values. Here 0.01, 0.002, 0.03 like that. 0.09 you will have values. Okay. Here you will have values. Here corresponding Z values you will have. In general way, what we will do? Here we will have 0.1, 0.2, 0.3 like that. Here some values are there. When mean and SD are given, we know Z value, we will find out area of Z, A of 0.2, you will get 0.2 beside value. 0.21, 0.2 line under 1, you will get 0.21. But in this problem, what happens? You need to search for 0.35 in this table. The corresponding Z will be Z1. Search for 0.35. If you search for 0.35 in the table, you will get that 0.35 at 1.4. You may have so many 0.35s in the table, but where that 0.35 starts, corresponding to that value will be Z, that is 1.4. So coming to here, in similar way, search for search for 0.1 in the table. If you search for 0.1 in the table, you will get that one approximately here 0.25. But left side we written Z2, this will be minus. Here x1, x2 values we know. x1 is, let x1 equal to 60, x2 equal to 30. So 60 minus mu by sigma equal to 1.4, 30 minus mu by sigma equal to 0.25. Now 60 minus mu equal to 1.4 sigma, 1.4 sigma plus mu equal to 60. Similarly, 30 minus mu equal to minus 0.25 sigma, minus 0.25 sigma plus mu equal to 30. If you solve these two equations by writing like this, you can get sigma value. By changing signs, you can cancel mu. You can get very easily sigma value like this. Here sigma value will get 1.4 plus 0.25, 1.65 sigma equal to, here also we changed signs here, plus minus, minus plus, plus minus, 60 minus 30, 30. So sigma is 30 by 1.65. This value you need to calculate. If you calculate that value, you will get sigma value. From that sigma value, if you substitute that sigma value in mu, you will get mu value. Okay, so like that, one can easily evaluate sigma and mu. 23.25 approximately. Substitute this sigma value here in this equation or in this equation, you will get mu. So like that, one can easily evaluate sigma and mu values. So calculate them using calculator also, you will get that value. Okay, any doubts you may ask. This is 18.18. 18.18 you will get 30 by 1.65. Substitute 18.18 here, you will get mu value. Okay, any doubts you may ask anywhere. Suppose the weights of 800 students. 800 students are normally distributed with mean 140 pounds, SD 10 pounds. Found the number of students whose weights are between 138 and 148 pounds and more than 152 pounds. Okay, this we need to evaluate. So first, what is given in normal distribution? In normal distribution, mean is given. Mean mu is 140 pounds. SD sigma is 10. Now we need to find weights between 138 and 148 pounds. That means this probability we need to find. Probability of 138 less than or equal to x less than or equal to 148. So for that, by taking x1 138 and x2 148, find z1 z2. Z1 is x1 minus mu by sigma. x1 is 138 minus mu value 140 by 10. So you will get z1 value. Like that, z2, x2 minus mu by sigma, x2 148 minus 140 by 10. Calculate those two values using your calculator. You will get z1 minus 0.2, z2 0.8. Now we need area between z1 and z2. What I am saying, this one we need x1 less than or equal to x less than or equal to x2. We made it like this. z1 less than or equal to z less than or equal to z2. So now draw the normal distribution curve. This is z line. Here z1 is negative, you will get negative here. Z2 is positive, you will get here. Negatives you will get in left side, positives you will get right side. Then the area between Z1 and Z2. The area between Z1 and Z2 we need to calculate. How you will get? Area of Z1 plus area of Z2. You need to add both the areas. That means A of minus 0.2 plus A of 0.8. Area of 0.2. So these you can get from the table. I said the Z distribution table. From Z distribution table you will get the values. A of 0.2 is 0.0798 and 793. And A of 0.8, see the table, 0.2881. If you add these two values, you will get 0.3674. If you multiply this one with 800, you will get exact value, the number of students who are between 138 pounds to 148 pounds. That value will be, after multiplying with 800, you will get 293.62. That means 293.6 means approximately 294 students have weights between 138 and 148. Like that, you can calculate the number of students who have the weight more than 152 pounds. That is, P of x greater than or equal to 152. By taking x1 152, find z1 x1 minus mu by sigma. 152 minus mu is 140 by 10. So you will get z1 value. So z1 value here 1.2. Now P of x greater than or equal to x1 implies we made it z greater than or equal to z1. Probability of, by multiplying this one with 800 we got this. Probability of z greater than or equal to z1. That means in normal distribution curve, this is z line. z1 is positive, you will get here z greater than or equal to z1. Greater than or equal to z1 means you will get greater than z1. Here you will get this part. That part you will get. Greater than z1 values you will get this side. So half area is 0.5. If you subtract from 0.5 this area, you will get A of z1 area, you will get required area. So 0.5 minus A of 1.2. This is from table. This is from table. Z distribution table. So from Z distribution table, if you see the table value 1.2, 0.3849. You subtract, you will get 0.115. So if you multiply that one with 800, you will get exact number of students who are more than weight 152 pounds. You have to multiply 0.115 with 800, you will get approximately 92 students. Into 800 if you do, you will get approximately 92 students will be the weights more than 152 pounds out of 800 students. Are you clear? Any doubts you may ask anywhere?